We're looking at this deposit from a super eruption, and yet we're over 50 miles from the source of the eruption.
The geologists have recreated what must have happened here on the day that Yellowstone exploded. Incandescent avalanches of ash raced out of the park in all directions.
So this is traveling at very high velocity, easily over 100 miles per hour across the land surface, and obliterating everything in its path.
It was extremely hot when it arrived here, and perhaps as hot as 1,500 degrees Fahrenheit. Twice a pizza oven. I mean, it's just very hot.
So what would it have been like to be standing on this spot hundreds of thousands of years ago, on the day when the Yellowstone ash cloud roared over the horizon?
The impact of this would be absolutely unimaginable. It would be, I think you would be disarticulated, burned, and unrecognizable, and it would be very difficult to find any of you.
All of the evidence about the size of the super eruption helped solve the mystery of the missing volcano. Scientists realized that the super eruption was so enormous that it must have blown the volcano to pieces. Swarms of mosquitoes show that explosive rhyolite lava underlies parts of the park. Obsidian glass 60 miles away reveals that ash flows spread for miles around Yellowstone. And thick layers of debris confirmed how gigantic an explosion this must have been. The problem now is the explosive legacy that the supervolcano left behind, because a deadly danger still lurks here, hidden deep under the ground. For nearly a century after Yellowstone National Park was established, nobody realized one astonishing fact: that the park is located inside one of the biggest volcano craters on Earth. It wasn't until the late 1960s that American geophysicist Robert Christensen realized that rock formations he had been studying for several years all around the edges of the park in fact formed a giant circular ridge. He compared his findings on the ground with a series of NASA pictures taken between 1966 and 1970, confirming that the ring was the rim of a giant crater 45 miles across. Parts of the crater rim are still clearly visible today, but the other edge is almost out of sight. Finding the crater coincided with another scientific discovery in a totally different part of the country. In California, scientists identified a strange thin layer of ash buried underneath the modern-day soil. The ash matched material from the Yellowstone crater. Dating the soil layers proved that the ash arrived 640,000 years ago. Scientists at last had a date for the Yellowstone supereruption. Ash was later found all over the western U.S., confirming the huge size of the eruption. At least 80 times the size of the 1883 explosion that destroyed the island of Krakatoa. And 2,500 times bigger than the 1980 eruption of Mount St. Helens. The almost unimaginable size of the Yellowstone blast means that scientists now call it a supervolcano. But that creates another mystery. In this peaceful landscape, where is the steaming hot crater that the volcano must have left behind?
Today, when you're looking out across the landscape, you see rolling hills and trees. So obviously there's not a big hole left in the ground from the eruption of the Yellowstone volcano. So something else has happened. One of the first processes was infilling with all sorts of volcanic lava flows. And if you look just down from the landscape toward those trees, you'll see one of the oldest lava flows that happened after the 640,000-year eruption.
Over hundreds of thousands of years, this flow has weathered into soil and been covered with trees. But elsewhere in the park are a different type of lava deposit, still bare of vegetation, because this lava was still erupting up until about 100,000 years ago. The later lava was far less explosive and more runny, and cooled slowly. It smoothed the harsh volcanic landscape into Yellowstone's softer countryside. That made Yellowstone at first more tranquil. But there's evidence here that the land was soon buried once again, this time by freezing snow and ice. The ice that polished the rocks has a story to tell. It offers crucial evidence about volcanic forces still shaping the park to this day. Its tale unfolds through the tiniest of clues. Scratches on the rocks reveal which way the ice was moving. They show the glaciers always slid the same way, outwards and downwards from an ice cap at the heart of the park. The only conclusion is that something pushed up Yellowstone Park so much higher than the surrounding hills that glaciers formed on the top. But what force could possibly be powerful enough to have raised Yellowstone's peaks up into the air? The first clue to help answer that question comes from Yellowstone's numerous earthquakes.
When the ground deforms, it creaks and groans like a Stradivarius violin, and the creaks and groans are essentially earthquakes.
The quakes are recorded by seismometers all over the park.
The earthquake monitoring is a critical part of the picture because it's the stethoscope that we have to really see and sense the heartbeat of the system.
Smith is investigating a puzzling geological mystery. Yellowstone has up to 5,000 earthquakes a year, even though it's in the stable heart of the North American continent. Scientists needed to know what was happening underground to shake the park so much. To find out, they plotted the precise locations and depths of earthquakes under the ground. So why are there so many quakes? The answer had to wait until the mid-1980s, when ever more powerful computers first let scientists see into the Earth. Seismic waves spreading out from earthquakes travel rapidly through cold rock, but slow down when the rocks are hot. The varying wave speeds can be translated by computers into color 3D images revealing exactly where hot rock lies under the ground.
Seismic waves propagate through the earth just like X-rays go through a body. And so we use the same physics to reconstruct the structure of the earth beneath us.
The seismic waves have outlined the park's underground structures, revealing a graphic history of what's happened under Yellowstone. They reveal this gigantic reservoir of molten rock which created Yellowstone's crater when lava erupted out, and the ground above collapsed into the space left behind.